Hey everyone, welcome to the Codex community call. We have community calls every month, and this community call is for the month May. And we have a lot of exciting updates from April to share across different teams within Codex. And we also have a special guest today for the community call. We have Eric, who is leading the Codex Marketplace team. So, yeah, make sure to retweet the Twitter stream so that we have a lot of eyes over here. And also follow us on our socials to stay updated with all things Codex. So, without further ado, let me introduce you to Eric, the Codex Marketplace lead.
Hey everyone, how's it going? I'm Eric from Codex. I'm the marketplace lead, and I will share some exciting features and updates that we're working on.
Yes, we just had a Codex offsite a couple of days ago. I'm back in London already, but then I think Eric is still around Croatia, which is cool. Uh, but then before we get started, Eric, do you want to just define Codex in a one-liner? How would you define Codex to someone who you meet for the first time?
Codex is a decentralized data storage network, and I guess you could say the main focus is censorship resistance, really. So, enables storage for things like network states.
Perfect. Yeah, I know we have a lot of definitions for Codex from different people across the team because a lot of things are moving rapidly, and Codex is a lot more community driven. So we definitely take community feedback into account. And right now, Codex is available in altruistic testnet, which means that the P2P layer is available for use when you use the current onboarding methods. And the marketplace is yet to be integrated into the current onboarding methods. And yes, luckily we have Eric with us today who will be sharing some roadmap about how this integration is expected to go forward. And we will also ask him with a couple of questions about how the Codex marketplace itself works. So, yes, if you want to get started, we also have a hands on section in the last part of this community call where I'll be running through the Codex installer to show you how to run a Codex node and also build on top of Codex. So, yes, the first question that I have for Eric before we go ahead with the monthly updates is how does the Codex roadmap look like for integrating the marketplace into the current onboarding system or like Codex as a whole?
So, into the onboarding system, I mean, it'll just be as simple. It'll be as simple as requesting storage. So, right now you can basically share your files or share your data sets, and eventually you're going to want to have some durability guarantees on those data sets to make sure that they're actually stored as they say they're being stored. So, in that case, you're going to need the marketplace. So, it'll just be as simple as requesting storage and setting certain parameters like the price, and then going from there. Pretty much, it'll take care of the rest for you.
Perfect. So, uh, Codex right now is just the P2P layer, like I mentioned earlier. So, if you have a local node running on your machine and if you have files stored on it, you can pretty much interact with the testnet to share the file with other peers. But then, if you want persistence, that's when the Codex marketplace comes in by making sure that the file stays on the network and does not simply go away if the local node hosting the file is down or deleting the data. So yeah, marketplace is probably like the spine of the whole Codex storage, apart from the marketplace things. And yes, going ahead with the community updates and also other highlights from uh, April, we did have a Codex blog published about comparison with Filecoin, where we compare Filecoin along with Codex in different perspectives, in terms of technical perspectives and also in terms of ecosystem perspectives, along with some use cases that can be built with Codex in the current state. And we also have a hands-on blog article about building on top of Codex, where we built a censorship-resistant peer-to-peer file sharing app with Codex and Vaku. So Vaku is the communications layer, and Codex is going to be the storage layer. And Vaku simply communicates the metadata that is stored on Codex. And we also had an engagement with DAP Learning, where we had a community call with DAP Learning, where we kind of tried to help them run their own Codex node and also build on top of Codex. And yes, these are the three main community engagements that we had in April. But apart from that, as I mentioned earlier, we had our IFT wide offsite. Institute of Free Technology is the one incubating a lot of projects like Codex, and you can find more about IFT at free.technology. And also make sure to check out our sister projects within IFT, which are kind of sticking to the same cypherpunk ethos. And yeah, we are happy to help if you wish to build on top of all these products and protocols initially. And we also had a lot of discussion about internal dog fooding with other projects and cross team collaboration with other projects. So a lot of it revolves around shipping consumer level apps that use all these technologies together. And we did have a Codex offsite after the IFT wide offsite, where we had client marketplace research and ecodev discussions take place, uh, along with a lot of retrospectives that kind of helped us understand how to improve as Codex. And we also have some upcoming engagements where we have Marina, the Codex growth lead, will be speaking at ETH Amsterdam on May 10th, just in a couple of days. And she will also be at ETH Belgrade later in the month. So, two new events to look out for if you wish to meet Codex folks in person. But finally, let's go to the most anticipated part of today's community call, the Q&A with Eric, where we have a couple of questions sourced from the community, also from a couple of other core contributors who wish to know about Codex. So getting started with the first question, it's about how does Codex currently function without a marketplace, and how can storage marketplace add more value into Codex? Eric, do you want to uh,
Yep. Yeah, sure. So Codex currently functions over a P2P layer. So it's not dissimilar to like something like BitTorrent. You can share data sets on the peer-to-peer layer, pretty much, but there are no guarantees. So similar to IPFS, you can store a data set on Codex without the marketplace, and there's no guarantee that the storage providers storing that data set are going to continue to store that data because there's no real incentives. So the marketplace adds an incentivization layer, and it enables the proving system. And yeah, it basically works by issuing challenges, random challenges, every so often, so every certain number of periods. And the storage providers must generate a proof with some entropy in the challenge and submit that on chain. And so if they miss proofs, they get penalized. And after a certain number of proofs, eventually the slot that they're hosting, which is a portion of the data set, will get freed. And there's also the validators as well. So the validators are responsible for monitoring the proof submissions. And so if there's a proof that's missed, it's the validators that will mark that proof is missing on chain.
Perfect. And for
Oh,
everyone of
sorry.
you,
One more
yeah,
thing. Yeah. So I didn't quite finish answering your question. Actually, what that gives you is it actually gives you durability guarantees. So if you want to make sure that your data is going to remain, like we said, is going to be where you want it to be stored on the storage providers, then the marketplace really enables this durability. So it's peace of mind for your data.
perfect. Yeah, I definitely think I'm not going to run my node for all the day. So if I wish to share some specific file, it should probably be accessible even if I don't have my machine turned on. So marketplace is definitely a great addition in terms of that.
Yep.
Yeah, for everyone out of you watching, make sure to ask your questions in the comments of Twitter or YouTube, wherever you're watching this, and we'll get it answered for you over here, or at least one on one on Discord. So, yeah, feel free to drop the questions. But moving ahead with the second question, this is a bit non technical, I would say. But then, uh, how big is the marketplace team, and what are the milestones that are being focused on with the marketplace team?
Sure. Currently, we are 4 people. Um, yeah. Current milestones. First milestone is focusing on testnet stability. So the marketplace is deployed in the testnet. It's just that probably most people don't use it, just based on the onboarding process, which is fine. But there are some people using it, and of course, we're testing it and finding bugs. So stabilizing the marketplace functionality that's currently deployed is our first milestone, probably most important one. And then I can kind of go into some sort of medium term features and things we're working on and future as well. Um, so we're currently implementing the Vault architecture, which is so we have marketplace contracts. The marketplace mainly runs on these contracts I was describing before, where contracts enable the proving system to, well, it enables proofs, and it also enables valid storage providers to be slashed if they miss a proof. So there's obviously funds being handled inside these contracts. So we're currently working on what we call the vault architecture, where any sort of money handling is isolated within the vault architecture. And inside the vault architecture, we kind of increasingly uh, lock down funds to for the reason that if there was some sort of an exploit, it's going to minimize the amount of funds that can be exploited. Um, it's quite in depth. I won't go into the details, but yeah, I mean, it's just sort of trying to mitigate the extent of damages that would happen in case of an exploit. So we're nearly finished integrating that functionality or the architecture into the current contracts. Um, we've also pretty much got data repair working in its preliminary state. It needs a lot of testing, but there's a lot more to that. But from the marketplace side, we've got data repair mostly working, which means if a storage provider goes down or gets slashed to the point where it's missed enough proofs, it gets slashed and it frees the slot, then we have this mechanism in place where that slot can be repaired and hosted by another storage provider. So that was actually something we did while we were together here in Split. So that's pretty exciting. We're also working on things like contract monitoring. So again, in the realm of exploits, the idea, when you have contracts deployed, you want to kind of see when something is being exploited, or at least, you want to avoid things like false positives. You got to set. There's a lot of contract monitoring systems out there, and so we're kind of exploring that landscape and trying to figure out the best way to monitor the contracts for malicious behavior. It's not an easy task, actually. We're also looking at, in the case of an exploit, what we would do. So we're starting to, the initial idea is to have a proxy upgradable contract just for the business logic. The Vault architecture would remain in place. So just the business logic would be able to be upgraded via proxy contract in the case of an emergency. We've also we're working on simplifying the sales process. So we kind of have a purchasing and a sales process. Purchasers are the people who want to buy storage, and sales are the storage providers that want to sell it. So we've added features over time, and it's kind of due up for a little bit of a simplification. So something we've been working on. We also have a feature in the pipeline. We need a better name for it, but it's called the Tepid Wallet. It's another sort of feature to. It's sort of like an account abstraction idea, where it's a contract-based wallet that is restricted to flowing funds to the marketplace contract. And so again, that's just another layer of isolation of funds in case of an exploit. or in case the keys are leaked somehow. Which is another thing we discussed, and how to properly use key management software to yeah host your keys locally, of course. Um, Looking further into the future, we there's a lot of work and research going into a validator network. So currently, the validators work by monitoring the uh, every period. It'll see whether or not a storage proof is required. If the storage proof was required, it will check to see whether or not a storage proof was submitted. And if it wasn't, then it will mark the proof as missing, and the storage provider will be penalized. So it's not an efficient way of doing things. We have further ideas around. So this is a you have to imagine that every storage provider for each slot that it fills has to generate a proof and submit it on chain. So that's sort of this one-to-one relationship. But we're thinking about how we can make this more efficient. So initial ideas are around bundling and aggregating proofs. So the validator network would effectively bundle a bunch of proofs. So when a storage provider submits a proof, it wouldn't submit it on chain. It would submit it to the validator network. Validators would bundle or aggregate some of these proofs, and one single proof would be submitted on chain. But you need consensus for that inside the validator set. So that's why they're calling it a validator network. Uh, uh, and further, we're looking into bundling slots locally. So if you're a storage provider and you are hosting a bunch of slots, instead of submitting each proof, again, generating and submitting each proof for each slot that you're hosting to the validator network or to on chain, aggregating locally all the slots that you're hosting and then submitting that to validator network. So there's some research going into that now, and I mean, these are thoughts. These are it's active research. So it's not anything that's has been in the process of being implemented yet. But there's going to be a move away from the current validator system as it stands now. And
Yes. Mhm.
that's probably about it for now. There's probably things I'm forgetting, but
Yeah. Yeah, again, like all these questions can be also answered on if you have any more questions about this and if you wish to know more about this in depth, feel free to join our Discord and ping Eric. He's going to be around the Codex public channels. So yeah, we also have a couple of questions from the community. The first question is about the proof generation. Does that happen on client side? Eric, do you want to take this question?
does the proof generation happen on the client side? Yes, the proof generation happens on the client side. So this is not my area of expertise, but basically there is a random sampling of the data. So using similar principles to data availability sampling, where particular chunks are queried and there's a proof generated locally on the client. So when you say the client, you mean Codex. It's a confusing term. Everybody uses the word client, but we use the role of client as the person who wants to buy storage, and the storage provider as the one who's selling. So it's generated locally on the storage provider, and then that proof is then submitted on chain. Yeah.
Got it. So another question from the community is about the marketplace contract itself. So I hope this is going to be deployed in EVM-based blockchains anyway. Do you have any comments on that? Because I know we are deployed on Ethereum testnet at this point, but do you want to add some comments to this?
Yeah. So we're currently targeting EVM, and it is deployed on the testnet, our testnet, and it actually is already deployed on status L2, and that's sort of our target. That is our target for now. So we're hoping to launch those contracts on the L2. They are already deployed, but they're not currently used from the L2. So that's the next. Yeah, I didn't really mention that, but that's actually one of the next high priority things for us is to move our testnet over to the status L2 so we can, yeah, we really need to test that out. But I mean, from a high level, like there's probably nothing blocking us from running on the status L2, but there's going to be subtle differences that are going to, create issues that we really need to test.
Perfect. So, yeah, going ahead with the next question, it's about the data redundancy part of Codex. So, does Codex enforce any minimum replication factors or minimum number of copies to say that a particular file is persistent in the marketplace?
It's a good question. It's no. Well, sort of. So obviously you can do no replication whatsoever if you wanted to just be altruistic. We also don't do replication. So Codex works with erasure coding. So what that means is that when you take your data set and you want to do a request for storage and you upload it to Codex, really what you're doing is you're chunking, taking your data set and breaking it up into smaller chunks. Then you're adding on these parity bits. I mean, parity chunks. It's not really the right term, but it kind of gives you the idea if you're thinking about it from a RAID perspective. So you're sort of extending out your data set. And what that gives you is some nice properties where you can lose a certain number of chunks and still be able to recreate the entire data set. So with each of those chunks, they're distributed across the network. So you have, resiliency built into that dispersal. So the minimum number that you need of participants that you need really depends on the sort of minimum amount of erasure coding allowed. And currently it's 3 nodes. So you're going to have to create a request for storage with 2 nodes and 1 tolerance. It's what we call tolerance. It's one of the parameters in the storage request. So that allows you to have 3 nodes total and allows 1 node to effectively, have a catastrophic loss, and your data would still be considered completely safe.
Perfect. I think the next question is about the alternatives in Web3, but then I think this is more of a BD related question. But do you just want to give a quick insight about
Yeah,
the Codex marketplace and how does it compare to the other competitors or like the
sure.
alternatives?
Yeah. I mean, so Filecoin and SIA both have a marketplace it's contract based, and so it's similar to ours. I mean, at a high level, like I didn't something I also didn't really describe before, but the way Codex works is that which is slightly similar to how Filecoin and SIA work. A request comes in with certain parameters, and the storage provider sees these parameters and enters into the contract. So it can say, oh, there's a certain price for this storage request, and that's good enough for me. I'll take it. I think with Filecoin, it works a little differently. It's not. I don't think that the storage provider is it picks and chooses which storage requests it would like to participate in. I think the client posts to it, but it's just like a subtle difference. It's very similar in terms of being contract based. And Arweave, I don't think even has a marketplace, from what I'm aware of. So yeah, I think this. So basically, the other thing that's nice about a marketplace is that it allows buyers and sellers to come together and form a market price. I think that's really an important aspect. Instead of what Arweave does is like it kind of says that this is the price you have to pay for this 200 years of storage or whatever it is. And you can kind of as a user sort of dictate, oh, that's a decent price if I look at Google Drive and et cetera. Whereas a contract based marketplace allows buyers and sellers to come together to dynamically form a price in real time. And so we think that this is a much better approach.
Perfect. So the next question is about the UX part of the marketplace. I know we do have an app called the Codex Vault app available at app.codex.storage, and people who have altruistic node can kind of interact with their node by uploading and downloading files over here in a nice looking interface. We also have it in the command line, but it's always nice on a interface. But then, how does the experience for using the marketplace looks like for you at this point of time?
Yeah, I mean, there's going to be this is going to be an area of continual improvement, but the idea is simply that a user needs to create a request for storage in the contract. And so the way it's done is by interacting with the Codex node as a client. So that was the client role I was describing before. So the Codex node has a REST API. So you could interact with the REST API however you see fit, like however whatever you think is best. You could just use curl. You could use Postman app. You can use the Codex JavaScript library that we have. But the easiest thing obviously is to use the really nice UI that we have, because it allows you to see like the parameters that you're setting up for this particular request. I think the areas of improvement are going to be more around like, hey, I requested this storage request, and how many nodes is it stored on? What's the current status? I think there's some of these features are in there, but some of them are a little, they need to be improved in terms of better UX. So we have some of this stuff. It's in mind. A lot of that's going to come along with the improvements that we're talking about for this sales design simplification. So the other thing I want to say about that is that it will also allow you to restore state in case of catastrophic failures or non-catastrophic failures. So this will also enable looking back in history to see which requests you had in the past, which were currently it's you can do it, but it's not particularly the most easy to use feature.
Perfect. So I think we can have one more final question for today before I set you free and go join the other folks in the offsite. Yeah, I already missed the offsite. So yeah, the final question is about. It's also related to the current state of Codex because obviously Codex will try to cater a lot of more use cases in the future. But right now, uh, on a on a economics perspective, I feel like Codex is optimal for large file sizes which are less dynamic, and we've been trying to educate the developers who build on top of Codex or think use cases on top of Codex in the current situation about this. And uh, yeah, do you have anything more to add on to the question? Is Codex currently feasible for small file sizes? If not, what is the technical reasoning behind the same?
Sure. Yeah, it's a good question and one we get a lot. I think a lot of the use cases that people tend to think of with Codex are around smaller files. So it's something that we are very actively looking into. Uh, the best way to use Codex for small files is the altruistic mode, and we're looking at a better way to provide. Currently, altruistic mode provides no guarantees. That's kind of what we described at the beginning. So basically, there's no guarantees that your data is going to be stored on a storage provider because there's no incentives to do so. So currently, no guarantees, but we're looking at an altruistic mode uh, functionality that provides weak guarantees. So there's a number of things we mean by weak guarantees, but just if you want the best, if you want guarantees that your data is going to be there, so full durability, then you need to pay for storage, and that is going to use the proving system that we have in place. And the proving system currently to generate proofs for small files requires CPU, hardware maintenance, bandwidth requirements. Basically, the electricity, the costs associated with running a storage provider to provide proofs for small pieces of data, the overhead of providing proofs is so great that it's not worth it for these small files. Uh, this question is worded also because what's currently in place. So currently in the test net, we have a circuit sample size of 5 samples, and that's also kind of in itself provides weak guarantees. Like we're the minimum sample size is going to be increased to 100 samples. So currently, what we have already much less resource intensive than what it will be when we go to mainnet effectively. Uh, the amount of so the amount of proving overhead is makes it economically unfeasible for users effectively. So the users will have to basically set a price that's high enough uh, that the storage providers will accept to host this data. And so, you know, there may be users that think that their JPEGs are really high value and they want to make sure that the durability guarantees for that JPEG are high. Fine, and if somebody wants to pay for it, great. But the effective cost, the price per byte will be effectively will need to be high enough to support the economic feasibility for the storage providers to do the work of generating these proofs. So I mean, just as a summary, it would be the altruistic mode is probably the best option. And if you're looking at it currently, the way it exists right now, there's no guarantees for altruistic mode. But in the future, we are looking for weak guarantees for altruistic mode. And if you want full guarantees, uh, generally the size of the file needs to be large enough to be economically feasible. Yeah, that's pretty much it.
Perfect. Yeah, you can try altruistic mode already, as Eric mentioned, and that will be the next section. But before that, thanks for joining, Eric, and answering all the questions. If you have any more questions, you can always reach out to Eric on Discord. He's in Discord. As do you want to just say your ID on Discord?
I think it's yeah. Right now, my display name is Eric, and I think it's
Oh yeah,
shows
perfect.
my time zone AEST.
Yeah,
So yeah, I'll be on
perfect.
there.
Yeah, he could have a Codex role on him. So yeah, you can
Yeah,
find him out on Discord and ping him if you have any questions. But thanks for joining again, Eric. I hope you have a great rest of your day at the offsite.
yeah. Thanks for having me. Appreciate it.
Perfect. So yeah, the final part of today's call would be the hands-on section where I'll be presenting my screen, showing you a bit about the Codex installer and how to use the Codex installer to run your own Codex node. So let's go ahead with it. And I'm going to share my screen now. I hope it's visible. Yep. So it's pretty much it's kind of easy to get started. You just have to run this command called npx codex storage and make sure to have npm installed on your machine before doing this. You can also find this on the documentation at docs.codex.storage, but we'll be showing you how easy it is to run your own codex node using the command line uh, right away. It shouldn't take you more than 2 minutes, and we are trying to improve the codex experience iteratively day by day. So once you have this interface, the command line interface, after you run the command, you should get started by going to the first step, which is downloading and installing codex. So hit enter, and this should get your node installed in a matter of few seconds. In my case, I have it installed already, and so it just gives me a nice pop-up saying that the Codex node is already installed on my machine. So let's go ahead to the second uh, option, which is run Codex node. I'm going to hit it, and again, I have the Codex node running in my machine, but this shouldn't take you more than a few seconds to get here. And yeah, that should be it. You already have a Codex altruistic node running on your machine, be it a Windows machine or a Mac or a Linux machine. We've made this CLI to make the Codex onboarding experience easier for all these operating systems. So yeah, that should be it. But if you already have a node running, make sure to get the altruistic mode role on our Codex Discord. This is just a role that we give to our early contributors who try to help a Codex node and give us feedback about the experience. To do this, you can go to the third option, which is check Codex node status, and go ahead to the node information in the second option, and you can find the node ID over here. you can copy paste the node ID in the Codex Discord server, and you can run the slash node command to get your Codex altruistic mode role. So yeah, that's pretty much it. You've already onboarded into the Codex testnet, and now let's make it a bit more interesting. You can also upload files using Codex and also download files using Codex. And this is using the altruistic mode. So be aware that there's no guarantees for the file unless marketplace is integrated. And yeah, so we've had a whole conversation about it. So do not expect guarantees for your file because it's just on your machine, and that's exactly what we call as altruistic mode, which showcases the peer-to-peer capabilities of Codex. But anyways, you can go ahead with the fifth option, which is to open the Codex app, or you can also use the sixth and seventh option to upload and download files using Codex right from the command line. But we will be going to the fifth option, which is the Codex app. Uh, so I'm going to pause my screen for a second and share my browser and take you directly into the Codex app now. All right, should be visible in a second. Perfect. I hope the screen is visible now. So you can get started by going to app.codex.storage. And once you're here, you can go through the simple onboarding in the Codex app, and you can pretty much go to the dashboard. But before we go there, we do have some requirements that you need to set up before using Codex, which is the internet connection, which is checked in my case. The Codex connection is not found, and I'll be explaining you the reason for the same. And the port forwarding is also a requirement. We have some port forwarding requirements listed on the docs, which you can find in docs.codex.storage, but also make sure to check out the Waku docs. They're another cool project, sister project under the IFT umbrella. But for today's community call, I'll be showing you Codex. But yeah, you can find the requirements for port forwarding right over here in the docs. You just need to set up port forwarding for 8090 and 8070, which is by default being used by the Codex installer. And these ports are used for discovery and transport, respectively. So if you're not familiar with how port forwarding works, you can find the instructions linked over this specific resource that we've shared. Shouldn't take you a long time again. Uh, but once you have that set up, this should ideally be checked over here. And that's when you can use all the capabilities of Codex. But in my case, I'm using a public network that does not let me port forward, unfortunately. So I'm going to use my DApp node, which I will be showcasing you. But before that, let me log into my DApp node. I'll pause the screen share for a bit. DApp node is a really cool onboarding mechanism that we have for people who don't wish to run their own node. You can kind of use a DApp node to run a node within a few seconds without having to run a whole bunch of commands, because we have some templates set up on DApp node. It's basically easy IPFS hash that you put into DApp node, and it's going to set up the Codex node over there for you. We also have the same on Akash. Akash is another cool platform that Codex team loves, and we have a Codex template over there, so you can simply go there and search for it. But before that, let me try showing you the Codex app in a minute. All right, I'm going to take a short 30-second break and come back because I need to just do some verification before I go into the DApp node. So stay tuned. All right, I'm back. So let me come back to the DApp node that we have running right now. So I have my Codex package installed over here, which is my Codex local get. And let me try interacting with the Codex app, which will be available over here. So this is the API. The app should be here. Yeah, found it. So going ahead with the onboarding again, you can see that the Codex connection is found right now. So yeah, the port forwarding requirements are also met, but the marketplace is yet to be integrated into this app. So you will not be able to use the persistent mode as we mentioned before. But now that we have the first three requirements set up, let me go ahead and you should be seeing this particular interface over here. And go to the files section, and you can upload files over here and also download files if you have a CID. But let me try uploading a file here. Maybe a picture of a cat. I have a lot of cat pictures that I always kind of use to demonstrate. So let's get the snoring cat uploaded into Codex. Yep, successfully uploaded. And this will be my CID for the cat. So you can also download another file that's on the Codex network if you have the CID of the file. So let's try doing it. Just enter it over here and hit the download button, and this should get it downloaded for you. Yeah, that's pretty much it. I just have my browser shared, so you won't be able to see the output of the file, but you can definitely see that the file is downloaded. Or alternatively, if you want to just download the file, just run the Codex altruistic mode, and then I'm going to drop this right into the share CID channel in the Codex Discord. So just copy the CID from there and enter it over in your download section and download it. And yeah, this is exactly where a problem pops up. What if you have a lot more files uploaded? Let's say I want to upload the second file, which is emocat, but then that's probably going to be a new CID. And this CID should be manually shared with someone that I wish to receive the CID. So every time you upload a file, you need to share the CID manually. And that's exactly where I wanted to build a small example app that leverages Vaku for transferring the metadata, which is basically holding the CID of files. So to do this, I built this app called share.hackyguru.com. This app is basically like a file sharing app that uses Codex and Vaku to share files between multiple peers who are in the same room. So you don't have to uh, kind of pass the CIDs again and again, but then you just join the same room, which in my case is XYZ123. I know a lot of you are already using this. I had some good feedback delivered to me earlier in Discord from a couple of them. So if you already have it running and if you are in the community call by chance, yeah, feel free to share a file and I'll have it in my received files. But if you are not running a Codex node right now, that's okay. I'm going to create another uh, tab just to demonstrate how it works between two tabs. So this could be Alice and this could be Bob, and they are in the same room, which is XYZ123, and also here XYZ123, which is by default. So let's try sharing something over here, maybe the same cat image, so that we can see if the CIDs are going to be the same. Yeah. So that uploaded the cat image 1.png into Codex, and let's see if I received it. Yeah, so Alice has sent 1.png and Bob has received it. And you can see that the content address CID is like ending with E26. Let's see if it's the same over here. Yes, exactly the same. So this is how content address networks work, and Codex is also a content address network. So if you upload a file into the network, It's not going to be duplicated again. Codex by as a network is uh, deduplicative in terms of uh, making sure that the file does not get duplicated in the network with multiple CIDs in multiple places. And this is actually a cool feature that a lot of other DSNs have also been doing in the past. But I also feel like this is an important property of Codex. So yes, that's how Cipher Share works. So in my case, I can just go ahead, upload a lot of files. Let's see how fast and how reliable this is going to be for uploading and downloading files. So have 1.png, 2.png, 3.png, and like 5 images being sent. And you can see all the 5 images are received in the other peer. So the communication between the two peers happen using Waku, which is the communications layer again, as I mentioned. So I always like talking about the Ethereum trilogy. A nice image that I usually share on every community call is this one. Let me try to open it in the news screen and make it bigger. So yeah, so when the Ethereum white paper was introduced, this is how the proposed decentralized app architecture looked like, where you have Ethereum as the consensus layer, Swarm as the storage layer, and Whisper for the communications. So imagine Codex to be the Swarm component over here, which is the file store or a decentralized storage network, and Whisper to be the dynamic comms, which exists as Waku right now. And Vitalik has already quoted about it as well. Vitalik has mentioned Whisper exists as Waku in his blog post called Making Ethereum Cypherpunk Again. So, yes, we are all from the same cypherpunk family. Codex is also a sister project of Waku. So, if you are already building on top of Waku, make sure to check out Codex. We are all a part of the Logos technology stack. And that should be it from me for today's hands-on section. If you have any questions, feel free to ask them on the Codex Discord or even on the comments of this particular stream. We'll be happy to help or answer this after the community call as well. And make sure to follow us on our socials on Twitter, which is X right now. My apologies, and Discord, and also on our Farcaster, which was recently started. So yes, that should be it. I'll meet you in the next month's community call again, and we do have some engagements in the middle. So I might meet you in between the community call that's popping up next month. uh, Again, all you have to do is to stay tuned to the socials to be updated to these things. So see you. Bye bye.